this is where things get more interesting and more useful. Okay. Some of those types are lists, tuples, which I made the accident of mentioning earlier. Strings are really a higher level type. Dictionaries or dicts, sets, and then one routine that's very useful that'll help us is a routine called len for length. All of these things are ways of keeping track of collections of things. So we'll talk about the three most basic ones to the language first. And all of these things are places where you can stick more than one value. How they differ we'll see in a little bit. These aren't the only high-level data types that are out there. As a matter of fact, one of the things that's very valuable about Python is that people can define their own. You can define your own data type if you need it. A list and a tuple are both ordered collections. When you put things into a list or a tuple, you're designating what order they go in. A dictionary, as we'll see, is an unordered list, but the values have keys that allow you to get things back out. You can stick any kind of Python value inside one of these things. So ints, and the values can have different types. You can have an int, a float, and a character string all inside, for example, a list. These things all do what you did with arrays if you learned to program in C or Fortran or something like that. So let's take a look at the list data type. So a list is a bunch of stuff. We'll worry about what that stuff is in a moment. That stuff is a precise term here. So we define a list by using the square brackets. So here I've defined a list. A is 1, 2, 3, 5, 7, 11. Okay. A contains all those things. If I ask, I can find out what a particular element is. So if I type print, if I type this, and then I type print a sub 2, I get back the value 3. Why 3? Well, the indexing starts at 0. That's a computer science-y thing. Why 0? I can't argue for that. Probably because in C it starts with 0. There's no good reason in Python for that. With a list, I can use equals to put something in there. So I can set A2 to be -3. So now my list contains 1, 2, -3, and the rest. A list can contain any other Python variable type. So here's a list. B contains 1, which is an integer. It contains first few digits of pi, which are a float. It contains a character string. The fourth element, element number 3, is a list in itself. So you can nest lists. You can put a list inside a list. And I can put a complex variable in. So I can define a list and specify everything, and I can also stick variables in. Those are square brackets, right? Those are square brackets. If you use, okay, I'll come back to what happens if you use. One of the nice things you can do with a list is you can reference it in different ways. So here I've defined my list again. I can ask for elements 1 up to 4. So element 1 is 2, element 2, 3, but not element 4. So that gives me 2 through 5, 2 through 5 here. I can say, give me element 4 through the end. I can say, give me the element from the beginning to 4. Element -1 references the last element. So 2 to -1 means everything up to, starting with the element 2, which is 3, up to but not including the last element. Okay, the difference, if you look here, it depends on where it is. Okay, it treats the first variable here as the first index here as where do I start. Okay, so when I start at element 4, I get the 4th element and possibly things after that. But when I ask for it to, when I specify that number as the last element, I'm saying not including that one. So I know this is a little weird. It's just the way that it works. I wouldn't have done it this way, but I never did this. I didn't set up Python. So this is just simply the way it works. So so 1:4 means start at element number 1 and go up to but not including element 4. But when I use 4 as the first index, it means start with element 4. Yes?
Just want to make sure I understand this.
Mm-hmm.
There is a little bit of an inconsistency because it looks like when you say A of 4 colon,
Mm-hmm.
it's not just up to, but it's up to and including the last one.
Well, the colon here, a blank entry means up to the end.
And including it.
Yes. Yeah. And including.
A number after the colon means up to it and not including.
Correct. That's just the way it works. There's no other way actually to specify up to the end. There's no -0. Okay. You can specify. So you'd get an error. But you can do this. And there are reasons why you might want to. Okay, so since A2 colon -1 has 3 values, I can put 3 values in to those there. So here I've referenced 3 values in A, and I've specified values for that. And now I have changed the 3, 5, and 7 to be zeros. Okay, that's a bit bizarre, but you can do it. If I say put in a third value, second colon and a third value, then I specify what's called a stride. And this allows me to skip elements. The default value is 1, which means give me every element. But here I've asked start with element 1 and give me every second value. So element 1 is 2, 0, 11, and that's exactly what I get out of this. Okay, I can even use that, and now I start with element 0, and I've assigned those to be the letters A, B, and C. So now I have A, 2, B, 0, C, 11. So, and here, if I just typed A, I would have gotten exactly the same thing, or print A, but I wanted to show you the syntax that you asked about, where you ask for the whole string. Okay. You can use the negative values to refer values from the end if you want to. By the way, notice that I added an extra comma here. What's the difference between this version and that version? The answer is absolutely nothing. The extra comma is simply optional. It doesn't care if it's there or not. But anyway, here I've referenced starting from value -3. That's -1, -2, -3, up to and not including the last element, -1. So I get 5 and 7. If I ask for it in the other order, I don't get anything. Here I've said I get the same thing as if I had said from element 6 to element 5. There's nothing there. However, I can use a negative stride to get the elements in the opposite order. Sort of weird, but cool. I'll get to you in 1 second. And here, I have asked for this array in the opposite order, and then this works. You had your hand up. Here is the list we're going to play with, and laying out the numbers in a sense and assigning nodes to each of these addresses makes life interesting. So we'll call this location node 0 up to node 6. And one of the places where I was wrong yesterday was that we can refer to any node above 6. There's no problem in terms of indexing in using numbers that are greater than our range. Likewise, we can also index from the end, and there's no way to specify from the end with a number because minus 0 and 0 are exactly the same thing. But this will be node number -1 through node number -6, or -7, -8, all refer to the same location. So therefore, if we address this by saying we want from 0 to 6, we get that line covering from here to there. Leaving out the indices gives us the same thing. If we say -6 here, well, -6 is an alias for 0. We get the same thing. But there's also no problem in saying -99 to 99. Okay? It won't give us more elements than are there. Now, if we try to refer to element A99, we get an error because there is no 99th element. But in terms of indexing, there's no problem in going off the edges. Okay? Now, if you refer to a null range, there's no problem. That's just a null list or null string or whatever it is you're working with. So 0 to 0 goes from here to here. So we get nothing. If we go from 1 to 0, we're always going from left to right. So again, we get a null list, both of those. If we go from 6 to -6, well, 6 to -6 again is a null list. Okay? I'm not going to sure it makes sense, but it's the way it works. Exactly. If we want to do this in Hebrew rather than in English, we want to go from right to left. We use a negative increment over here. But there's something that's tricky that happens when you go to negative increments. The way that these are labeled changes. Okay, I have yet to figure out exactly why, but it probably has to do with the way that these things are addressed internally. Okay, so now 4 refers to this position rather than that position. So 0 doesn't give us the first element. So here we go from 4 to 0. So we start at this location and we go there. So we get 7, 5, 3, 2. 0 doesn't give us the first element. Perhaps. I don't know. I can't explain this. In all honesty, this slide is about 15 minutes old. If you want to go get this element over here, you either need to leave it out, okay, or you need to use negative addressing to get it. And that's actually wrong. That should be for -1. As I said, that was... you know what, let me do that one correct that while I think about it. Okay. All right. The slicing is quite complicated, and I want you to see it. You'll have it in your notes. You probably won't use all of the stuff that's here. And you'll find that for the kinds of things that you're talking about, where you want to slice a list and iterate over it. But you probably won't do it the way you're thinking of. All right, there's some more fun things you can do with lists. Lists have methods or functions associated with them, and a lot of them are they're mostly different from what we saw before with strings. We can append something to a list. So here I've appended the logical value 13 to the end of a list. If I want to put it in a particular place, I'm putting 17 before element 0. So that shows up as the beginning of the list. This function is a little weird. Most things, you might expect a.sort to do what string.upper did, which is to return back a sorted version of the list. But it doesn't do that. It sorts it in place. So a.sort doesn't return a sorted list. It changes a to be sorted. It's just the way that it works. Later in the language, they added a routine called sorted, which does what you'd think sort should do. You can take a list and you can use it as a last in first out stack, if you know what that is. If you ask to pop a value off the list, it gives you the last element and it drops an element off of the list. You can also specify you want to pop from a particular place, so you can also pop from the beginning if you want to have a first in, if you want to have a that would be a first in first out stack. All right, what else can you do with lists? So two ways of defining a list. One of which is you define all the elements in the list when you need it. Second one is that you define an empty list. This is A followed by A is equal to a list that contains nothing. Then I can start appending things into it. There are languages that allow you to do this. You can define an element that doesn't exist and add into an array that way. You can't do that in Python. And if you try it, you'll get an index error. Lists do have addition defined for them. And if you add two lists, you get a single larger list with all the elements in it. Okay, that brings us to tuples. Now, somebody before had asked, do we use square brackets for lists? And the answer is yes. Tuples use parentheses. Okay, and you can do a lot of the same things. You can address them, and you can slice them, and you can do all the sorts of things that you can do with lists, except for one thing. You can't change them. When you define a tuple, it cannot be, you can't do anything to change it. If I really want to take element number 2 out of the tuple and change it, I need to slice the tuple up, make a new tuple with 2 in it. But I can't change it. So that's the main difference. One other difference about tuples is that the parentheses are actually optional. Okay? I would wish nobody would ever do this, but I must admit I do it myself sometimes. You can define the tuple without the parentheses. Okay. The other thing, so a tuple, just like a list, can contain anything. You can define an empty tuple, but you can't add to it. So an empty tuple is not necessarily very useful. The only gotcha with tuples is that if you want to define a tuple with one value in it, you have to use that comma. What happens if you don't use that comma? Well, it thinks you're just using parentheses like in an algebraic expression. So that comma converts this into a tuple. Tuples do have addition, so if you want to add tuples together, you can do that. You might think, wait a minute, why can I add tuples if they're immutable, if they don't change? And the answer is that I'm creating a new tuple when I do that. These ones haven't changed, but I've created a new one. Okay, so tuples are a lot like lists. For tuples, you use parentheses, and the parentheses are optional. Lists always use square brackets, and they can be changed. And they're different. You can add a tuple and a tuple. You can add a list and a list, but you can't add a tuple and a list. That operation's not defined. You can you absolutely. Yep. Yep.
Can you nest a tuple inside a list?
I'm sorry. Can you what's that?
Can you nest a tuple inside a list?
You can nest a tuple inside a list, and you can put a list inside a tuple. You can put anything inside anything.
Can you change the list inside the tuple?
Yes, you can do that. We'll get to that one. Not today, but we'll get to that. What's that? No. You could if you have a tuple inside, if you have a list inside a tuple, then you. Okay, let's show you. Okay, so let's start by making. I'm going to do this in 2 steps. I'll start with my list. And how many elements do you want in my list? 3. Okay. 1, 2, 3. Okay. So now I'm going to create a tuple that consists of my list. I need that comma. Okay. Okay. So there's my tuple. And you'll see that it looks a little different. So if I say I have a tuple that contains a list, if I try to change tuple value sub 0 to be 0, it would help if I put the equals in there. It won't let me do it. Okay. However, I can say tuple element, ask for element 0, and then element 1 of that, I can change that. Okay, you asked for it. Sure, I can say type T, and it tells me it's a type. But element 0 is a list. And okay. Yes. So if I want to make that into a if I want to take T and I want to make it into a list, I can say list T, and now it's a tuple of tuples, or tuple. Yeah. So yes, you can change. You can cast things. You can say I want to convert something to something else. Only if it makes sense, though. I don't think taking my tuple and masking what it is as an integer makes any sense. So it won't let me do it. Okay. And by the way, I mean, I probably, if I'd thought about it, I would have done this as a float. So now you can see that I've stuck that my tuple is made up now of a list, 1 element, and that element contains 2 integers and a float. Okay, and if I really wanted to make you confused, I could make that into a tuple of strings. And I'm being cruel. So now I've got a tuple with a list inside it, and my list has got a tuple inside it. Would you ever want to do these things? Maybe. Maybe. Hard to believe it, but maybe. Okay. All right, so we talked about strings before, but it's worth mentioning that strings, just like tuples, can't be changed. You can index a string. You can use slicing. So here I've taken every other letter from working backwards, but I can't change it. There's no sort method for a tuple. If you want to sort a tuple, you can do it, but you have to do it by creating a new tuple. And you can do that. Okay, so let's see what else. For people who have never programmed in any sort of scripting language, this one may seem a little weird. Okay? But when a lot of times when you work with storage of information, you want to say, okay, here's something that I want to have a lookup value for, and these are called dictionaries or dicts because it's sort of along the lines of what we do with a dictionary. You want to go to a dictionary and find the value for and. You go to the dictionary, you look up and you get back the meaning of and. So there is a value associated with and. If you go to look in the dictionary for ANDX, there's no value associated with it. So a dictionary you can think of as it's a kind of an array that has values associated with it, and the values are defined by keys. So, oops, I didn't want to go to that. I just want to show you that here I start out with an empty dictionary. Dictionaries get these squiggle brackets, and I define the values that I want to put in here. So I define a value corresponding to the key 1. I define a value corresponding to the key 2. Here I define a value corresponding to the string key 2. Here I define a value corresponding to the float key 2.1. That's not necessarily a good idea, but we can do it. We can also define the same dictionary in one swell foop. Here's the key, the value, so on. And if I look at what it is, it shows me the values. So here's the key, here's the value associated with it. And I can then look things up in that dictionary. So this is just another way to store information. One should be very careful, though. There is no meaning associated with the order that I've defined these. Okay? By chance, no, I haven't even gotten them back in the order that I defined them. I defined them 1, 2, string 2.1, but when I display them, I get them back in a different order. I get these two are reversed. So there's no inherent order to a Python dictionary. Can I? Yeah. I mean, in terms of defining it? Oh. Yes. Yes. I could even do something where I come up where something that evaluates to a string too. Right. Right. As long as I can do anything. What's that? As long as it comes up with, I mean, as long as I come up, stick something here that corresponds to those 3 letters, I will get the value back. That's correct. Yes. Both. There is the question was, is there a data type associated with both the value and the key? And the answer is yes. The key and the value both have data types associated with them. You can make your key a tuple. Okay? Sounds really bizarre. Why would you want to do that? Well, what if I had a list of structure factors? And I want to look up what's the structure factor for the 001 reflection. Well, that's the 001 reflection is very well described by a tuple containing 001. So then there's a value associated with 001, which might be complex. Can the elements of a dictionary be sorted? The answer is you can sort the keys if you want to. As a matter of fact, I think that may be on the next slide. I had wanted to stop sometime between 1:15 and 1:30, but I'm not managing on that. I hope you'll indulge me. I'll try to go. I think I just have a couple more slides here, and then we'll finish up. So the answer is yes. If you get methods coming with dictionaries, and so one method is over here to get the keys. So for this dictionary, the keys are 1 to 2.1 floating the string. I can get the values associated with them. Items gives me back the dictionary as a bunch of pairs, tuples of value, of value and key and value. I can ask if the dictionary has a key, and if it has it, it'll come back true. If it doesn't have it, it comes back false. One really nice routine is this get routine. If I say a square bracket 2 close square bracket, I get back the value associated with that. But if I did a square bracket 2.2 close square bracket, I get an error. What if I want what if I want my code not to give me an error? Well, if I use get, it will either give me the value associated with this or a default value. So this is a way you can look up something in an array, and if it's not there, get a default without having to use this in an if statement, if it's defined. Remember, the default value, if you don't specify this, is none for this routine. You can get none back if you just if I did a get 2.2 close parenthesis, the response, the value I get back would be none. I didn't want to throw that one at you at the moment, but that is true. And that's exactly the kind of thing that in Python thinking is where you would use none. Okay. Sets are a little like lists, except sets only keep track of the unique elements. So here I've defined a set going from 3 to 0 and then back up to 3. It's only kept the unique elements. You can do nice Boolean algebra type stuff where you combine sets and things like that. And it's something that was added to Python more recently. This wasn't originally in Python, but it turns out it's really useful for certain things. Okay, let's see. One thing, and this is I think where I end, that's really useful when you're working with collections, be they tuples, lists, strings, dictionaries, is to know how many elements are in it. And the length, len, operation will give you back the number of elements, and it works just fine on any of these data types we've looked at. Question for you guys. What do you think would happen if I asked for what's the length of an integer? Anybody? Length of an integer would be 1. Length of an integer is an error. Length only applies to lists. So if we take this and we ask, say a equals 1, error. An integer object doesn't have a length associated with it. Now, I can, let's see, I need to do that. I made it into a tuple. That's pretty confusing, but all right. What's that? Absolutely. So a string has length. Yes, you can have length of a dictionary is the number of key pairs So let me just go back to the slide. Here's a dictionary. It's the same one I used before. It has 4 pairs of elements. 1, 2, 3, 4, and actually it doesn't. I don't have the. I don't have that shown, but the length is 4. Both of them are 4. Yes. That needs to be changed. Okay. Okay. All right. Homework. Okay. Specify the data types of all those values. Okay. And it's not cheating to type them into Python to ask Python what the type is. Okay. So I apologize because I really did want to end a little bit before now, but let me give you a chance to ask questions though before. Yes. When is it good to use lists versus tuples? In general, you'll use tuples in places automatically because it's very convenient and you won't think about it. And I'll show you some examples of where you use tuples later on. But if you're thinking about it, use a list. Yeah. There's a lot of places where you'll use tuples but without thinking about it. I'll give you one simple example right now. When you want to when you want to return a value from a function, you're only allowed to return one value. So if you want to return more than one value, you say value, comma, value, comma, value, and what you've done is you've made a tuple. But you could make it into a list if you want to. Okay? But you'll find that a lot of people, without thinking about it, just use tuples there. But there's no reason you ever have to use a tuple, as far as I can think of. But it's so ingrained into the language you use it sometimes without realizing it. Another question? Yes. No, there's stuff built in. I don't use it very often, so I'm not quite sure what we'll get. But let's try. Yeah, so there's lots of stuff there. Yes. Yeah. There's all sorts of stuff. It has to do a little bit with how you define things, and we'll talk about doc strings and stuff like that when we start defining code. Yes. Yeah, that's built into Python. The help command. Okay, you had a question, Joe. That would be sets. Okay, where you want the OR of two sets. So if I wanted to do that, you want to add them value by value. You have to cast them as numpy arrays. And the addition of 2 numpy arrays, as long as they have the same lengths, will be element by element addition. Okay, Frank?
In your sort example for the list, it was essentially an ascending sort. Is there a way to do descending?
Yes. The way you would do a descending sort is you would specify an optional parameter to sort. Let's see. Let's see how you would get that. A equals, I think, there we go. So that's how you find out, and it tells you that this one's pretty terse. I'd go to the web to find out a little bit more information, but but it gives you a hint here that if you say reverse equals true,